thank you guys for coming. Again, sorry about the small room again. If you guys were here last week, we had a planning meeting. We were in a room like a quarter of this size with about this many people. So, but sorry that the room is still small. The registrar gave us this room temporarily. Next week, we'll have a bigger room. And the following week, we'll have an even bigger room. So stay tuned for that. Anyway, welcome. So yeah, this was actually last week right here. We were in one of the Marston rooms in the basement, and then we just found an empty classroom. We moved there. We were still full. So yeah, maybe you guys you could sit down in the front. I don't know if you guys whatever you guys want to do. I'm sorry. Yep. All right, I'll start off with a couple announcements. This weekend on Saturday, as we will every Saturday, we have a hackathon, which is basically a time where we get together, do some homework, work on projects, whatever you want to do. You just hang out with people. I definitely recommend you join. Tuesday, so every Tuesday we're gonna have another meeting, basically at 6:15. It will probably, I meant to put the time there, but yeah, 6:15 on the Tuesday. Probably be on Git version control stuff. It will be in this room, which is bigger. There will be pizza if Eric buys it. So be there too. Okay, so here's what we're going to do today. First, we're going to say a little bit about what is this club, since not everyone was here last week when we talked about it, so we'll rehash that a little bit. And then we'll go into what is good software development. And then based on that, we'll kind of flow into design by contract, which is a good way to kind of think about your code. So Society of Software Developers, what we are, independent club, open to everybody, weekly meetings on stuff that you will like actually learn from. We try to do things that will like you don't usually learn in the classroom, that will help you get a job or help you while you're in a job, things like that. Tuesdays at 6:15. Yeah, one of the best parts is the community here can talk to anybody you want. A lot of people are really smart here that I've seen. And yeah, so thank you for showing up. So here's our mission statement, which we'll be directly touching on today. We want to help developers build correct, maintainable software. So exactly what does this mean? Correct is pretty simple. It works the way it's supposed to. It solves the problem. Maintainable is a much bigger thing. It's kind of a broad concept here. We'll explain it a little more later, but code that's easy to understand, update, fix, and adapt over time. So this includes things like the code being readable. You format it so that it's not one-time use. Maybe you could use it elsewhere in places that make sense. You also don't want to be too complex and use it in so many places that if it breaks everything. Things like that. We'll go into more detail there. First, I want to show this video. Hopefully there's sound. Okay, first of all, who can tell me what movie this is from? Yes, sir. Now, what did we get from this? Is this a simple system? Not terribly simple. It does get the job done, but it could be simpler, right? Now, what if somebody bumped the table a little bit and maybe moved the machine like an inch? Would it still work? Probably not. It would probably break. Now, that is not, if this were software, that wouldn't be good. You don't want to just change one tiny thing and break everything. Goodbye, goodbye. I understand, room's too small. So yeah, we want our code to be stronger than that, be resistant to changes, or be even improved by changes. So here we go. Okay. Okay, so here's some general good practice guidelines. We want to minimize complexity. So what we just saw there was highly complex. Though it got the job done, it's maybe not optimal. There are ways you could make it simpler and work better. Define errors out of existence. So this I'm going to touch on later, but you want to format your code such that certain errors are not even possible to happen. Now, this can't be done for all errors or anything. You're not going to get bugless code ever, essentially, but there are ways to make it really hard to get bugs. And I'll give an example later. So, something about comments. A lot of people say, like, you might think comments in your code, that's great. Everybody loves comments in their code. But a lot of people go overboard. You say, you write x equals 2. You don't need a comment that says this sets x to 2, right? It's pretty clear. You don't need to go overboard here. It actually ends up making the code harder to read if you do that. So now here's some metrics you can use or you can think about when you're writing code. You want your code to be all of these things if possible. Extensible means it's easy to upgrade. You write your code so that when you're thinking about the future when you write your code, you know that when you need to add this extra feature, it'll be easy to add and it won't ruin everything. You won't have to refactor 1,000 lines of code manually to make it work. It'll be easy. Maintainability. It's easy to update your code. You know, if you add something new, you don't need to change this part of the code to make that part of the code work. Everything is, and when if you're using libraries, the libraries change, then hopefully you won't need to change everything too. Just make it as resistant to problems like that as possible. Readability, pretty clear. Don't put everything on one line, like a lot of Pythoners do, you know. And obviously there's a lot of other things you can do, like separating your logic out into clear parts, using functions properly, things like that. Clarity, it's kind of really similar to readability, but you want your code to do what it says it's going to do and be obvious what it is supposed to do. Things that can help are like documentation, things like that. Hello. Efficiency, you don't want to go forward and use like all your resources to like find an item in your array. Maybe use a hash map or something. Instead of looping through a million different entries in a database, you can just go exactly to the one. Efficiencies, things like that. So imagine you're in this situation. You're at a job. You find a bug. Okay, so your code hangs. It doesn't throw any error message. It doesn't even stop executing. It just keeps running forever. Okay, you narrow down the issue to this function. So read this function. First of all, try to figure out what this function is supposed to do. Okay. Yeah, it is written like this. It's called my function in the code base because they're bad at software engineering. So when anybody who finds out what this code is supposed to do, that's right, Fibonacci sequence. Now, it was really probably hard for most of you to tell what it was because the naming was so terrible. You actually had to read the code to figure out what it did, not optimal. So what if we just changed the function name? That would be way easier. You didn't have to read anything to know what the function does. In case any of you aren't familiar with the Fibonacci sequence, it's just you take the previous two numbers, add them together, and that gives you the next number of the sequence. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. So this function is recursive, which if you haven't used a recursive function before, super cool in my opinion. It just calls itself. So you can see right here, let's pretend you put 3 here. You called Fibonacci of 3. Then since it's not 0 or 1, you return Fibonacci of 2, and then that would go through and do Fibonacci of 1, and then you'd get 1, right? So kind of have to think through it a little bit, but when you get Fibonacci of 3, it'll return Fibonacci of 2 and 1, and then those are your previous terms, and it eventually all falls back to this base case where it returns either 0 or 1. Okay, so we know what the function is supposed to do, but there's still a problem. Anybody know the problem? Or a possible problem that could come up?
Gonna keep moving in a negative number.
Correct. If you put in a negative number, you see these parts here, it's going to go Fibonacci of -2 and -3, and there's no base case because it will never become, n will never become 0 or 1. So it will just keep recursing over and over without finishing. So yeah. That's actually brilliant. But it won't give you what you want. Well, that will give you, but then it would overflow probably. Yeah. So you'd eventually get an error of some, probably an overflow. If yeah. Anyway, that's what happens when it goes on an infinite loop. You just keep going. Yeah. Example of non-efficient code, even if it gives you something in the end. I just want to get to the help. There we go. Okay. So I can't remember what's next. Okay. So now, in order to fix this issue, let's think about it in terms of a design by contract. So what should go into this function? Positive integer, right? Because that will give us, like, if we say n equals 3, that means we want the third Fibonacci number. So we know this function should only take in positive numbers, but for some reason, someone put in a negative number. Should we handle this? Maybe. Probably. If we don't handle it, we'll get this thing where it doesn't return an error, it just hangs. So we'll probably want to at least do something about it. Anybody have any idea ways we can solve this? Yes.
Add another base case.
Yes, absolutely. What would the base case be?
If n is less than 0, maybe just like return 0.
Could return 0. But I mean, that might be what I have next. Yes. Well, almost. That's a good idea. I think I have it next, but we'll see. Here's one way we could do it. We could say if it's less than 1, just return whatever it is. So if you input a negative number, it will just spit that negative number back out. So it doesn't crash. But is that what you wanted Fibonacci to do? No, it doesn't even make any sense to do that. But it wouldn't crash at least, right? But then later down the line, you'll find, why is this Fibonacci thing returning a negative number? That doesn't make any sense. So maybe that's not the best way. So this is kind of what you suggested. Another base case, if it's less than 0, then return -1. -1, we could just check to see if it returns -1, that means this function had an error. We should see why it got -1. Now this is a way that a lot of people would do, maybe. Can anybody see why this would not be a great idea? It's kind of subtle, but yeah.
For some reason you were using the result as part of like some other operation, like correct.
Exactly, yeah. Because if you don't check for a -1 every time, then you might get a -1 and then could ruin a lot of things. So anybody have an idea of another way we could fix this might be better?
Exception.
Yes, I think that's what I have next. Yes. We could throw this error. So then whenever anybody puts a negative number here, we throw the error. Now, this is probably what most people do, and it's probably a pretty good solution, but you might not always want to do this. You might want it to be able to, not throw an error at all. You might want to define this error out of existence, not even allow this to happen in the first place. Anybody have any idea how we could do that? That's exactly what I was thinking. There we go. So in case you're not familiar, an unsigned integer can only be positive. So there's no way you could possibly pass in a negative number now. Now we don't have to handle any error cases. So this is like purely concise. There's some reasons you might want to not use an unsigned integer. Some languages don't have unsigned integers, but this is a nice way to handle it at least. So I want you guys to think about this one as well. Imagine you have a bank account, or you're coding a bank account, okay? You have this function deposit. What are some considerations about the input, the output, if there's any, what deposit will do? What about the input? What does the input have to be? Right. Is there anything about that amount of money that you maybe could or could not put in there? What about a negative number? Okay, Okay, exactly. Sorry. Okay, so what happens if we do put a negative number? What should we do? Let's pretend there's no unsigned double in this language. Okay.
What language is this?
Pseudocode. It does, I don't know, it doesn't matter. It's mostly like Java, but pretend the language doesn't matter. Yes.
We need to tell the user something, to get an error.
Yeah, we could definitely throw an error just like before. Yeah, these are valid ways to solve the problem. We could, of course, add another function that says withdraw and then only allow positive numbers in each, something along those lines. Okay, so that went a little shorter than I anticipated. But I encourage you all to stay and get to know your neighbors. Because a big part of this club is the community. Yeah, do you have something?
Yeah, I had a question about like throwing exceptions.
Yeah, go ahead.
I remember in some project that I had to do this back, I created a program that would basically keep running this one function, and at some point the function would just have to like stop, so the loop would stop running. And the way I decided to do that was to basically make it so that the function would actually throw an exception when that happens, but then the exception would be immediately popped and then the loop would be exited, something like that.
Okay.
I forget
Yeah,
how that
yeah.
works. Would you say that's a good idea or not a good idea?
I don't know if I completely gathered everything there, but it did throw an exception and catch an exception
Well, the idea
and then
is that
stop it.
the program was made in such a way that the function will always throw an exception at some point, and that exception is always caught. When it does. when it does pop.
So I don't know if that's too good. Did you want to say something on
Yeah,
that?
it sounds like your issue can be solved a lot better by a while loop. Right.
I'm trying to remember the context in which I did this, okay? Because I honestly would have done that if it were that easy.
So you're saying the only way to get out of this loop was throwing an error. You couldn't break out of it.
I'm trying to remember. I can't remember how it went.
I imagine a break would have been good. Anyway, anybody have any questions? Yeah, go ahead.
Yeah, let's throw
Oh, you're right. What? Wild lol. Thank you for that. Anybody have anything else? Okay. Yes.
Wait, so back to the
Yes.
do you think it's possible to get like linear time, or not even linear, just a constant time state without using the platform or the platform that we have to use?
I'd have to think about it. I think maybe hash maps or storing values.
Wait, so you can do your job, you can demo it, so you have
Demo it.
different, you had another parameter as an array. and that
Right.
makes sense for every time. You can Python and then just add cache decorator to the top, and it does it for you completely.
There we go. This is what we have our community for. Yes.
So you don't have to recalculate them again.
Yes, this is true. This is true. We can optimize in a lot of ways.
Did you say linear time and space?
Or as little as possible, but.
Okay, yeah, so if you were to use dynamic programming, that would be linear time and space, but obviously that would be exactly O of n, so it wouldn't be like as little as possible.
If you save the values, you can make it, I think, longer. Yeah, no, if you have like 2 pointers, like A pointing to the first left number and B pointing to the second, you can just like slide into pointers in space over. That would then be O of n space. No, you're using two, you're not using an array, you're using like actually I think it's 3 variables. You're just creating like the first two you add to get the third to get the next Fibonacci, and you just shred the within 3 variables. So kind of like a train with three values.
Yeah. So yeah, we definitely could optimize this in a lot of ways.
If I like
Eh.
before way of.
Yeah. A formula. Oh, I don't know. I assume there might be. So the question is, would you want to do all of that. Like Blake said, it might be hard to maintain. So the real answer is it depends on your situation. Is it okay? Are you going to be putting huge numbers into this? Are you just going to be using it for like 3 or something? Might determine what you want to do. Does anybody have anything else they want to add or anything? Okay.
How big is the room gonna be next time?
Next time, oh, the room is going to be so big, unbelievably big. I actually don't know.
Where is that?
Okay, yeah, so this is McCarty Hall A. Yeah, it's like just southeast of the Rights, I think. Yeah. Yeah. It's one of those buildings. There's like McCarty A, B, and C, I think, and they're like next to each other. We used to have meetings in there every week, actually. So yeah, hope to see you guys at the hackathon. Now, I want you guys to talk to your neighbors, at least introduce yourself, say hi. So you might find your best friend. You never know. Okay. Thank you guys.